Hello students, welcome to the session. Today we'll be discussing about the definite integration. So d by dx of small f of x is equal to capital F of x. Then integral a to b capital F of x dx can be written as small f of b minus small f. This is the value. Definite value is coming. That's why we call it as definite integrals. And definite integrals mainly useful for finding the areas and limit as the infinite sum also will do. So there are the certain important properties are there in this one. Let us look at one after one. F of x is a be the primitive or antiderivative of f of x. So derivative of f of x is, okay, here what happened? Antiderivative of f of x. Antiderivative of f of x is capital F of x. Means derivative of capital F of x is small f of x. Okay. So what is this one? Integral antiderivative f of dx is equal to, generally we write f of x plus. But when you apply the limit a to b, so you will not take this c value. Directly you will be writing f of b minus f of a. Next. Here, and when you are taking this one integral a to b, the function has to be continuous. For example, in a to b, f of x is discontinuous in between the point. For example, integral for 0 to pi tan x dx. When such thing is there, tan x is not continuous at pi by 2. So I need to take 0 to pi by 2. Then we'll go with pi by 2 to pi. Okay. And here, integral a to b f of g of x dx. F of g of x and g dash of x dx. Simply what we will do, we will take g of x is equal to t, g of x is equal to t, and we'll go. This is the substitution method. And here this is the integration by parts. What is the integration by parts? You must have studied already during the integration. What is integral u into v dx? Okay. First function into integral of second function minus integral of derivative of first function into integral of second function. So you have to apply the limit after finding this integration from a to b and here a to b. So that is the thing by parts when the by parts is there. A to b f of x dx or a to b f of t dt, a to b f of z dt. So definite integration is independent of the variable. This is independent of variable. You can keep on changing. Accordingly, the values also goes to change. And these are very important properties. Integral a to b f of x dx is equal to minus integral a to b to a f of x dx. Here lower limit and upper limit interchanged. Next, f of x is continuous in a to b. Integral a to b f of x is can be split into n number of intervals. Means actually integral a to b f of x dx means this one. Like here a, this is b. So if someone is asking integral a to b f of x dx means this portion. So between, for example, here C1 is there, C2 is there, C3 is there, C4 is there, C5 is there. Like this way you can write C1, C2, C3, C4, C5, C. So this one plus this one plus this one, you can write that. And important properties, what are the most important properties are integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. And very important property, integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. So extension of this one only, here this one, instead of 0 to a is there, we can take this one. If f of x is equal to a minus x, integral 0 to a f of x dx can be written as 2 times integral 0 to a by 2 f of x dx. If f of x is equal to minus f of a minus x, integral 0 to a f of x dx will be equal to 0. This is another one. Okay. Integral a to b f of x. Very important property. Integral 0 to 2a f of x dx is equal to 2 integral 0 to a f of x dx if f of 2a minus x is equal to f of x. 0 if f of 2a minus x is equal to minus f of x. Minus a to a f of x dx is equal to 0 if f of minus x is equal to minus f of x. What you call this one? Odd function. What we call this one? This is called odd function. Is equal to 2 integral 0 to a f of x dx if f of minus x is equal to f of x. What we call this one? Even function. See, derivative of odd function will be equal to even function. Derivative of even function will be equal to odd function. Similarly, integral of even function will be odd function. Integral of odd function will be even function. Next, if f of x is periodic function with periodicity, integral 0 to nt f of x dx is equal to n integral 0 to f of x dx. Integral a to a plus nt f of x dx is equal to n times of 0 to t f of x dx we can write. Integral a plus nt to b plus nt f of x dx is equal to integral a to b f of x dx where n is the integer. Integral mt to nt f of x dx is equal to n minus m integral 0 to t f of x dx. When this is the periodic is there, we will be taking these things. Okay. Next one is, this is by substitution x plus c is equal to t. If I take x plus c is equal to a minus c, so t is equal to x is equal to a minus c, so t is equal to a, and when x is equal to b minus c, t will be equal to b, and x plus c is t, and dx is equal to dt we can write. So you can write, for a moment you can write this one, or replace t with x, there is no problem. And this is the derivative of the integration of the function. See, for example, you have u of x to v of x into f of t dt. So this is going to come as g of x. Now I want the differentiation. G dash of x is equal. Substitute the upper limit in this one. F of u of x into u dash of x minus, substitute the lower limit, f of, so this is v, first one, and this is u. Substitute u of x into derivative of u of x is u dash of x. If this is the constant, this portion will not be there. If this is the constant, this portion is not there. So it is the derivative of the integration. Now here, method of express to infinite series as the definite integrals. What is this? Like limit n tending to infinity 1 by n, f of r by n is there. This value will be equal to integral 0 to 1 f of x dx. So what will happen now? This r by n is equal to x. Change in r by n, r is equal to 1, 2, 3. So change in x will be equal to 1 by n. Now, and here limit n tending n is equal to 1 to infinity. Oh, here r is equal to 1 to n. I'll write again this one. So method integration, this portion is limit n tending to infinity summation r is equal to 1 to n 1 by n f of r by n is equal to integral 0 to 1 f of x dx. So here what is happening? R by n is equal to x. So change in x is equal to 1 by n. R is equal to 1, x is equal to 1 by n. N tending to the value goes to 0. R is equal to n, x is equal to 1. For example, here instead of n, 2n is there. You are going to take 2. And also the same thing you can also write limit n tending to infinity 0 to n minus 1 1 by n into f of r by n. This is also we'll write integral 0 to 1 f of x dx. There is no problem. And this is the successive reduction. Integral 0 to pi by 2 sine power nx dx or integral 0 to pi by 2 cos power nx dx. The value will be n minus 1 by n into n minus 3 by n, etc. The last value is 1 by 2. Okay, 1 by 2 into the value is pi by 2. Because if n is even, finally you are going to get I naught. So I naught means integral 0 to pi by 2 sine power 0 x dx. This means you will be getting dx, so pi by 2 will come. So this value will be keep on writing. Finally you need to write pi by 2. If n is odd, you keep on writing whatever the value you are going to get. You can keep it there itself. Okay? Only when n is even, pi by 2 is going to come. Integral 0 to pi by 2 sine power mx cos power nx. Here these are the cases. N is equal to 1. N is equal to 1 means integral 0 to pi by 2 sine power mx dx. Okay. N is equal to sine power mx cos x. So what happened? F of x into f dash of x. So sine power m plus 1 x by m plus 1. When you apply the limit, you are going to get. Similarly, m is equal to 1 also, you will be getting the same answer. So, where m and n are different values, you will be getting. See, both m and n are even, you will be getting pi by 2. Both m is even and n is even, pi by 2. So, simply you need to write like this, n minus 1 by m plus n into n minus 3 by m plus n minus 2. Like, whatever the last term comes, then start with m minus 1 by m into this value ends with m plus 2 nana. Then m minus 3 by m minus 2 like. Both are even numbers. Finally, you write pi by 2. If both of them odd numbers or one of them odd number, whatever the number comes, you can stop it there. These are the very important as per your exam point of view. 2 is not there. 0 to pi by 2 log sin x is equal 0 to pi by 2 log cos x is equal minus pi by 2 log 2. 0 to pi by 2 log tan x is equal 0 to pi by 2 log cot x is equal 0. Why? You know, integral 0 to pi by 2 log tan x dx plus integral. So this value will be equal to integral 0 by 2 log of integral a to b f of x dx. That property you take. Tan pi by 2 minus x cot x dx. So cot x is 1 by tan x, you can write. So minus 0 to pi by 2 log of tan x dx. So what will happen? This is equal to this. When you add value will be equal to 0. Integral 0 to pi by 2 log of 1 plus tan theta or pi by 4 to pi by 2 log of 1 plus cos theta is called pi by 4 log 2. Integral 0 to pi by 2 1 by sin x plus cos x is equal to this value. Okay. So these are the some important things you need to remember for the competitive exam. These are the very simple. If you take I is equal to integral a to b f of x by f of x plus f of a plus b minus x dx. What is this one? Integral a to b. This value will be f of a plus b minus x by f of a plus b minus x plus f of x dx. Now what is 2i? And you add up this one, integral a to b dx will come. So b minus a will be the answer. So I is equal to b minus a by 2. Okay. And this is integral a to b f of x dx plus integral f of a to f of b f inverse of x dx is equal b into f of b minus a into f of a. What is this? This is like y is equal to f of x. This is the a value, this is the b value. So corresponding value is f of a and corresponding value will be f of. So f inverse of x, what will happen? You need to write, okay, this area will be equal to b into f of b. So total area minus this area. So you are going to get, because with respect to y-axis, if you look at, this is the what you are going to get. So this area plus this area, you are going to get this one. Okay. So with this one, I'm concluding the session. See you with another session, problems on definite integration.